This is SpaceTime Series 25, Episode 108. Coming up on SpaceTime, stunning new images of the Jovian ice moon Europa. NASA's SpaceX Crew-5 launches to the International Space Station. And Iran claims it's launched a space tug capable of moving small satellites into different orbits. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Juno spacecraft has now completed its close flyby of the Jovian ice moon Europa. In the process, it's captured some stunning close-up images which are actually raising more questions than they're answering. The new high-resolution observations, taken at an altitude of just 358 kilometres, are showing detailed views of a puzzling region of the moon's heavily fractured icy surface. It was the closest any spacecraft had been to Europa since Galileo came within 351 kilometres of the moon back in January in the year 2000. And the new images are exposing new information about the crisscross network of grooves and double ridges, pairs of long parallel lines indicating elevated features in the ice, and some weird-looking stains, possibly linked to something from below erupting out onto the surface. NASA's lead co-investigator Heidi Becker says the new data is unlocking an incredible level of detail. She says the features are so intriguing, understanding how they formed and how they connect to Europa's history is telling scientists about the internal and external processes shaping the icy moon's crust. The Europa flyby has modified Juno's trajectory, reducing the time it takes to orbit Jupiter from 43 down to 38 days. Juno was launched back in August 2011, achieving Jovian orbit insertion in July 2016. The 3,625 kilogram spacecraft is studying the chemical composition of Jupiter's immense atmosphere and cloud structure, peering deep below the obscuring cloud tops to probe the convection currents and thermal engines driving Jupiter's atmospheric circulation patterns, and the spectacular surface weather features, cyclonic storms, and iconic salmon and cream-coloured bands. Juno is also measuring Jupiter's gravitational field in order to better understand the internal structure of the solar system's largest planet, as well as its magnetic field, polar magnetosphere, and auroral activity. Jupiter contains more mass than the rest of our solar system other than the Sun combined. Juno was placed into a highly elongated polar orbit, especially designed to avoid as much of Jupiter's damaging radiation belts as possible. This allows the spacecraft to swoop down and skim just 3,400 kilometres above the swirling Jovian cloud tops, before being taken back out again to more than 8.1 million kilometres. Last year, Juno undertook a close flyby of the solar system's largest moon, Ganymede, and it will undertake the first of two flybys of the Jovian volcanic moon, Io, next year. Io is a fascinating world, the most volcanic place in the solar system. And it's got an interesting link to Hollywood. Io was the original name chosen for the Hollywood blockbuster movie Alien. Unfortunately, the film was released in the same year as the movie 10, and the producers didn't want to confuse the two. Getting back to Europa for now, and Europa is the solar system's sixth largest moon, with about 90% the equatorial diameter of Earth's moon. The frozen world has a salty global liquid water ocean deep below a kilometres thick icy crust. The water is kept liquid, despite the moon's extreme distance from the Sun, by the constant flexing of the planet as it orbits around Jupiter. Known as tidal flexing, this bending of the moon generates heat, and that heat's enough to keep the moon's subsurface water supply liquid. In fact, Europa has more liquid water than all the Earth's oceans combined. And that's raising speculation that maybe, like Earth, there could be life below the icy crust of Europa. Only time will tell. This report from NASA TV.
The search for life beyond Earth begins with understanding life on our home planet. And that story, the story of life on Earth, may have begun in our oceans. And that's because, of course, if we've learned anything about life on Earth, it's that where you find the liquid water, you generally find life. So what if I told you that there is an ocean out there beyond Earth? An ocean in our solar system that has been in existence for billions of years. It's an ocean that is perhaps 10 times as deep as Earth's ocean. It's an ocean that is global and may contain 2 to 3 times the volume of all the liquid water on Earth. It's an ocean that exists beneath the icy shell of Jupiter's moon, Europa. So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today, and it's been there for much of the history of the solar system. We used to think that in order for a world to be habitable, you had to be at just the right distance from the sun or whatever your star was, such that you could have a liquid water ocean on the surface. Now, along with liquid water, life as we know it needs 2 other keystones. The first is the building blocks for life, the stuff you find in rocks. And the second is some form of energy to help power life. And here's where Europa is a real game changer. It is far, far out from the sun, and yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life. The question of whether or not life exists beyond Earth, the question of whether or not biology works beyond our home planet, is one of humanity's oldest and yet unanswered questions. And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.
This is SpaceTime. Still to come, NASA's SpaceX Crew-5 launches to the International Space Station, and 3 Russian cosmonauts return safely to Earth after their 6-month stint on station. All that and more still to come on SpaceTime. The SpaceX Dragon capsule Endurance has successfully docked to the space-facing forward port of the Harmony module on the International Space Station. Docking came 2 days after launching aboard a Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center in Florida.
Crew-5 displays are configured for launch.
Copy. And Nicole, Josh, Koichi, and Anna, on behalf of the entire team at SpaceX, Good luck, Godspeed, and enjoy the ride.
And those words from Nicole Mann, the first female commander of a Dragon. Upon liftoff, you'll hear a number and letter combinations which mark different abort zones throughout the flight, as well as some performance calls. The first two are 1A and 1B, and those signify the first stage and will last up to the very north tip of North Carolina. The next are 2A through 2E, and those will come into play once the second stage kicks in, lasting from the top of North Carolina all the way to the tip of Newfoundland in the northern Atlantic. You'll also hear a spot that is to be avoided, and you might hear Shannon or forward to Shannon, and that actually refers to Shannon, Ireland, meaning they would target off the east coast of Ireland if they were later in that second stage and did need to abort for some reason. So the next major milestone that we're looking towards will come just seconds from now, and that will be when engine chill begins on the first stage of the engine.
That's right. So engine chill is basically when we take a little bit of that super chilled, densified liquid oxygen and we flow it through the turbopumps of the Merlin M1D engines on the first stage. This helps to prepare the turbopumps and avoid any thermal shock to the hardware when they see the full flow of liquid oxygen during ignition. We're also expecting the inclusion of prop load for the RP1 on first stage to wrap up at T-minus 6 minutes. LOX load continues to be underway on both first and second stages, again wrapping those at T-minus 3 minutes and 2 minutes.
And after that, we'll hear a number of call-outs related to Dragon's flight computer. Some will be
Stage 1 engine chill has started.
And you did just hear that call-out that Stage 1 engine chill has begun. Coming up in just about 45 seconds, we should expect to hear that RP1 load is complete. RP1 load is that densified kerosene or rocket fuel that will help propel the crew into orbit. All of that RP1 is loaded into the first stage, and we are standing by to hear that it was loaded into the second stage as well.
Again, we expect that to wrap at T-minus 6 minutes.
Stage 1 RP1 load is complete.
Great news there, the RP1 load is now finished.
And coming up, we'll also hear the call for Dragon to configure for terminal count. And then it will be transferred over to internal power. And then we'll hear that propellant tanks on Falcon 9 are getting ready to pressurize, which helps add some additional rigidity and structural support as we get ready for strong back retract.
That strong back will retract a couple of degrees at first, and then we will see it swing open completely just shortly or at the moment of
Falcon 9
liftoff.
tanks will be pressurizing for strong back retract. Dragon is in configure for terminal count.
All right, there we heard that call. Dragon onboard computers have now taken control of the vehicle. As I mentioned before, first stage LOX or liquid oxygen loading is underway and will wrap up at T-minus 3 minutes. And the second stage will wrap its LOX load at T-minus 2 minutes. Launch teams continue to report no issues and everything remains green and for an on-time launch.
Retract has started.
Strong back is part of the transporter erector, and the transporter erector is what provides the liquids, the gases, and the electrical connections to the vehicle. It's also what we use to integrate the vehicle in its horizontal position.
Stage 1 LOX load is complete.
And there we go, all of the oxidizer loaded on Stage 1. Soon we'll hear that Stage 2 LOX load is complete, and that will be the last propellant call-out we'll hear today.
Dragon is in terminal count and is on internal power.
All right, there we heard the good news that Dragon is now on internal power.
Dragon is in auto idle. Stage 2 LOX load is complete.
There we heard the call out. Falcon 9 is now completely fueled. All of its propellants, so
Gas closeouts are starting. Expect loud landing.
nearly 1 million pounds of liquid oxygen in RP1 now on board Falcon 9. It is fully loaded and ready for launch.
And coming up at T-minus 1 minute, we'll hear that Dragon is in countdown. Its flight computer will switch to countdown mode, and we'll hear that the flight termination system on Falcon 9 is armed.
FPS is armed. Falcon 9 is in startup and is now controlling.
And there you heard it,
Dragon is in countdown.
Dragon's flight computer in countdown. The flight termination system now armed.
We should get the final go for launch from SpaceX launch director Mark
Dragon,
Soltis.
SpaceX. Godspeed. Go for launch.
SpaceX Dragon, go for launch.
SpaceX
T-minus
reports
30
go.
seconds.
Crew reports go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power. And liftoff. Stage 1 propulsion is nominal.
Vehicle is pitching downrange.
We're now at T plus 35 seconds into the 5th rotational crew mission on board Dragon and Falcon 9.
Stage 1 throttle down.
Falcon 9 engines throttling down to help pass through the period of maximum dynamic pressure.
This period is known as max Q, and once the vehicle... There we just heard that the vehicle is now traveling faster than the speed of sound. Once through max Q, we'll throttle those Merlin engines back up.
Max Q. Stage 1 throttle up. Stage 1 throttle.
Stage 1 Bravo.
Copy 1 Bravo.
That call out for 1 Bravo means we're in the second and final abort mode for the first stage, continuing to get good performance. The crew is already pulling over 2 Gs, and next up is going to be a couple of events in rapid succession. First will be engine chill on the second stage and back engine. And there you heard that call out. And then we'll have MECO, or main engine cutoff, where the 9 engines igniting will cut off in preparation for second stage separation. Then we'll see the single Merlin vacuum engine on the second stage ignite and continue to carry the Crew-5 astronauts to orbit.
Just like we did on first stage, that MVAC chill is intended to help pre-chill the hardware prior to the full flow of that densified liquid oxygen.
Stage 1 throttle down.
At this point in time, those 9 Merlin engines are beginning to throttle down in preparation for MECO, or main engine cutoff.
Standing by for MECO.
And MECO.
Stage 2 Alpha.
And stage separation confirmed. Copy 2 Alpha. Ignition.
Obviously confirmed by the loud cheer behind us here at Mission Control Hawthorne.
Second stage is lit and continuing to carry the Crew-5 astronauts into orbit.
First stage making its way back to Earth. We will be attempting to land it on our drone ship, which today we are using Just Read the Instructions.
Acquisition signal, Bermuda.
And we did hear that acquisition of the ground station in Bermuda. The first stage is continuing to make its way back to Earth, and the second stage is going to continue.
SpaceX, trajectory nominal.
Another good call, trajectory nominal.
Dragon copy.
Confirmation there from Commander Nicole Mann.
Second stage is going to continue firing until a little over 8 minutes into the flight, really doing the heavy lifting now, getting the crew into orbit.
Everything continues to look nominal on both first and second stages. As I mentioned before, the first stage will be making a landing on one of our drone ships, which is currently parked a couple hundred miles off the coast of Florida in the Atlantic Ocean.
Dragon, SpaceX, trajectory nominal.
Good confirmation there that we have good trajectory.
The second stage now traveling over 5,400 miles per hour. Crew is pulling a little more than 1 G right now. That's going to continue to ramp up, peaking just before we get to second stage cutoff here in just a few minutes from now.
First stage will be performing 2 separate burns, a re-entry burn where we reignite 3 of the Merlin M1D engines on the first stage. We ignite the center engine into radial engines to help slow it down as it re-enters the Earth's atmosphere. And then the second final burn, and that will be the landing burn on our drone ship.
And the single MVAC engine that you see,
SpaceX, trajectory nominal.
the single MVAC engine that you see is continuing to fire. We did hear another call out that trajectory is nominal. Crew heading in the direction that they are supposed to be.
AFSCM.
This single engine can produce over 220,000 pounds of thrust in the vacuum of space, now over 200 kilometers in altitude. We will start to hit events now in a rapid succession as the first stage continues to make its way back to Earth and the second stage continues its burn, just a couple minutes left in that burn.
We are coming up to the re-entry burn, which, as I said before, we ignite 3 of the 9 Merlin engines to help slow the booster down as it re-enters the dense part of the Earth's atmosphere. As the entry burn completes, we'll be in the final...
Stage 1, entry burn startup.
There we heard the
Stage 2,
call out.
STS is safe.
You can there see it on your screen that that entry burn has been initiated.
And as that entry burn completes, we'll be in the final different abort phases here shortly, which essentially correspond to areas along the very northeastern seaboard of the U.S.
Stage 1, entry burn shutdown.
Everything continues to look nominal for both the first and second stages.
And the crew with the second stage still attached is now traveling over 13,000 miles per hour.
We're about 10 seconds away from SECO 1.
Copy, Shannon.
Shannon,
Stage one, transonic.
that call out for Shannon, Ireland, indicative of our final abort zone. After this, we'll see second stage shut off, and we'll be listening for confirmation of a good orbit, which tells us the crew and Dragon are exactly where they need to be.
There we had confirmation that the
Stage
MVAC
one landing burn.
has shut down simultaneously. The entry.
Dragon SpaceX nominal orbit insertion.
And you heard that call for a good insertion. We will coast for a few minutes.
Stage one landing leg deployed.
And as you can hear by the clapping and cheering behind me, Falcon 9 has landed on our drone ship, just read the instructions, parked off the coast of Florida.
Signal. Okay.
And again, that second stage separation will be coming up just a couple of minutes now. We do coast for a few minutes
Acquisition signal to Finland.
after second engine cutoff to allow any rates or motion to dampen out and settle. We did hear that the crew has been successfully inserted into a good orbit. Again, the crew is still attached to the second stage.
We are expecting stage separation to occur in just over a minute from now, about 1 minute and 8 seconds. And that's when when the second stage will separate from the Dragon trunk. The Dragon trunk is the part of hardware where we are able to house the cargo that is able to be exposed to the vacuum of space, as well as the solar panels which help power Dragon while it is on orbit. After stage separation, we will have nose cone deployment. Now that Dragon is in the vacuum of space, we will be able to open the nose cone and expose that forward hatch, which is what is utilized to dock autonomously with the International Space Station.
And that nose cone does stay closed for the flight uphill to help protect all of the guidance, navigation, and control sensors. We are standing by for second stage separation. And there is separation.
Dragon separation confirmed. On behalf of the entire launch and recovery team, it was an honor, a pleasure to be a part of this mission with you.
Awesome. Thank you so much to the Falcon team. Woo! That was a smooth ride uphill.
SpaceX Crew-5 mission carried 4 new crew members to the orbiting outpost for a planned 145-day expedition. They'll join 3 new crew members who arrived last week aboard the Russian Soyuz MS-21 capsule from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. In a sign of continued cooperation in space station operations, despite the worsening situation back on Earth in the wake of the Russian invasion of Ukraine, the Dragon crew included a Russian cosmonaut, just as the Soyuz flight had included an American astronaut. These space swapsies ensure that both Russian and American crews retain an ability to operate each other's spacecraft in the event of an emergency or when one type of vehicle has been grounded for an extended period of time. This is SpaceTime. Still to come, Iran claims it's launched a space tug capable of moving small satellites into different orbits. And later in the science report, a strange blue goo-like living organism discovered living on the seafloor of the Caribbean. All that and more still to come on SpaceTime. Three Russian cosmonauts have returned safely to Earth aboard their Soyuz MS-21 capsule, landing under 3 bright orange and white parachutes on the Kazakhstan steppe, about 150 kilometers southeast of Zhezkazgan.
The Soyuz MS-21.
Standing by for the thermal protection and the... We see the removal of the thermal protection. The pressure is descending. Excellent.
The crew under the command of Oleg Artemiev reporting that the crew is feeling great. The main chute has been deployed, a clear sky awaiting the arrival of the crew. The familiar beeping of the radio beacon on the Soyuz, providing telemetry back to the Antonov 26 fixed-wing aircraft. That data being relayed to the Russian control team outside of Moscow.
The crew feels great. The seats have been armed nominally. We're seeing 1 kilometer.
Everything proceeding by the book. The Soyuz descending to its target. The Rosaviatsa search and recovery forces are in place. The Mi-8 helicopters flying in a circular oval pattern around the landing zone, awaiting the arrival of the crew. Oleg Artemyev continuing to report back that the crew is feeling great.
300 meters per the altimeter.
300 meters off the ground. Clear skies, temperatures in the mid-40s Fahrenheit, awaiting the arrival of Artemyev, Matveyev, and Korsakov, just minutes away from wrapping up 195 days away from the planet.
The crew feels great. We are ready for landing. Getting ready for landing. Copy 250 meters, ready for landing.
All is going very well. The Soyuz just seconds away from touchdown. And touchdown. Touchdown confirmed at 5:57 a.m. Central Time, 6:57 a.m. Eastern Time, 4:57 p.m. at the landing site. The soft landing engines firing just a second or two before touchdown. Artemyev, Matveyev, and Korsakov home.
The crew had undocked from the International Space Station's Prikal-Nadir port some 3.5 hours earlier. The team had spent 195 days in orbit, flying up just after Russia's invasion of Ukraine. In fact, they made a bit of a surprise when they arrived at the space station wearing yellow and blue jumpsuits, which bore a striking resemblance to the Ukrainian flag. But it turns out sometimes a jumpsuit is just a jumpsuit. In this case, they just happened to be the colours of the cosmonaut training school the three had attended. Helicopter recovery support teams landed minutes after touchdown to help extract the crews from their charred capsule, which the Russian Federal Space Agency Roscosmos had adorned with anti-Ukrainian slogans prior to launch. After post-flight medical exams at the landing site, the cosmonauts were quickly flown to Star City near Moscow for debriefing. Iran claims it's launched a new space tug capable of docking onto small satellites in space and then moving them between orbits. Iranian state media showed images of what they claimed was the Saman suborbital explorer. However, the term suborbital sort of defeats the claim that this thing is capable of moving spacecraft in orbit. What the images were actually showing appears to be a Safir anti-ship cruise missile. It only has a range of around 25 kilometres. Of course, Tehran has a history of making unsupported claims about its space program. These have included some notable pictures of new Iranian spacesuits, which were quickly shown to be nothing more than children's dress-up costumes. So what's really going on? Well, the announcement just happens to come as Tehran's trying to shift attention away from the ongoing demonstrations across the country following the death of 22-year-old female protester Masazina Aminiat at the hands of the state's morality police for refusing to wear her headscarf. The Islamic Republic does have a very advanced space program, but despite lots of claims of scientific endeavour, its real purpose is to develop a long-range ballistic missile to operate as the delivery system for its clandestine nuclear weapons program. This is SpaceTime. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.